Welcome to Savoir Labs, I'm Jamie Goodyear. Today we're going to learn how to install Ollama on your PPC64LE system. Up next. We're going to start with a shout out to VivaPowerPC's website, where they have outlined the set of instructions you're going to need to follow to install Ollama onto your PPC64LE system. They're pretty straightforward, but we're going to go step by step and show you on my Raptor Blackbird how we do this and get it up and running. Then we're going to run some benchmarks to find out how well this runs on the PPC hardware. Our installation steps will have us build CMake 3, install Golang version 1.23.4 or higher, pull the latest Ollama code and make a couple of small edits, compile it, and then we're going to run the Ollama-Benchmark as we've done in our prior videos. So let's dive into this and get onto the console. Okay, we're on our console. Let's take a look at what we have on our screen before we start working. Right above me, you can see the output of BTOP showing the CPU utilization memory usage on our system. And on the left-hand side, we have our terminal. Let's dive in. So first thing we need to do is get CMake. I have already downloaded a copy of CMake, and the commands we're going to use to set this up is bootstrap script. This is going to take a little bit of time to run, so we're going to fast forward to film while this is building, and then I'll catch you on the next step. Okay, now that we have done the bootstrap, we are going to run the make command. We're going to pass into it to use a processing node, so that way it'll get completed reasonably quick. And now that we've completed the build of CMake, let's go ahead and get this installed. And now we have CMake on our system. The next command we're going to need to run, and I've already done this on our system, but I want to do this for completeness, is show you our installation of Golang. So on our system now, if we do a CMake version, we should be able to see the version of our CMake, 3.31.5, and we can see our version of Go, which is 1.23.4. Okay, we now have the basic parts of the tool chain we'll need to build out Ollama. So our next step will be to clone the Ollama repository. Now, I've already gone ahead and cloned out Ollama from their GitHub. There is going to be one set of changes that was provided to us from the VivaPowerPC website, and I'm just going to do a git diff so you can see the change in the code. In the readline term linux.go file, we have to add an additional import, in this case for Golang org xsys Unix, and a pair of constants get changed over to the Unix settings. With those, we are now ready to build Ollama on our PPC64LE. So let's begin our build. I'm just going to clear the terminal so we can see all of our steps. We're going to start with CMake -B build. And then we are going to do CMake build. This will take a bit of time, so we may fast forward the screen again until the end of the compilation. Okay, we've built Ollama, so let's give this a quick test run. We're going to type go run.serve, and I'm going to put this into the background so I can send some additional commands. We're going to notice there's going to be a lot of extra output that comes out from system. We're running it here. Just rest assured that it is actually up and running. We see here now that Ollama is available. We're going to give it go run dot, and I want to first take a look to see if we have any of our remaining models. I've already run this on the system before, so I want to check if we have our models. And we can see that our regular collection is there. If they were not there, we would have just run go run.pull and then the model name. So let us do a quick test of a model, and then we are going to take a look at doing some benchmarking. Let's start with the Llama 3.2 model, just to show you what it looks like when it's running. And we see we have our prompt. We're going to say, why is the sky blue? All right, we got a response, and we'd see that the CPU was completely pegged while it was running, because we do not have a GPU installed right now in the system. So of course the CPU is going to be doing all the work. We can see our evaluation rate came out to 9.82 tokens per second. I think we're ready to start doing some benchmarking. Before we begin our benchmarks, I just want to show you that we have taken the Ollama-Benchmark from our prior videos, and I'm just going to bring up the Git repo from there. This is the one from Girling, and we made one small change, which was to tell it to run our go run command, minor stuff. So let's go back to our Ollama, and we are going to start by benchmarking Llama 3.2. And Llama managed to give us a 9.65 tokens per second. And now we'll set up to run the Mistral. And with that, we got 4.19 tokens per second. Let's move on to the first of our DeepSeek models. And DeepSeek R1 1.5B managed to give us 16.15 tokens per second. Let's try out the 8B version of the model. And DeepSeek managed just shy of 5 tokens per second. Okay, let's set up for our last of the DeepSeek models, the 14B. Wow. And the 14B model finished with just shy of 3 tokens per second. Let's go to our results. For comparison purposes, we've included the results from our Dell R250 with the RTX A1000 card and the Apple M4 Mac Mini. Our Blackbird Power 9 system did give us results. They weren't exactly fast. The two best models for testing was the Llama 3.2 and DeepSeek R1 1.5B LLMs. Those two worked the best. The Llama gave us about just shy of 10 tokens per second, and we saw about 16 per second on DeepSeek. Those two represent the ones that I would want to be using if I'm trying to develop something that was, say, like a chat application. You want to get some streaming values back relatively quickly. Larger models, it's purely CPU bound. It takes quite a while to get that into system memory, and that first response takes quite a bit of time to get to you. To improve this, we'd want to install an NVIDIA RTX card with the PPC64LE drivers and be able to see if Llama can pick that up and give us a much speedier experience. That being said, if you have access to systems like that or the larger Raptor systems like the Tellus 2, and you have many more cores, I'd love to see the numbers if you can post them in the comments down below. With that being said, I want to remind all of you to please like and subscribe to our videos. We do love hearing comments from you too down below, so please hit the bell and get the notifications. That being said, have a great day. Cheers.